So today is the day we develop the unit circle. Today is that day, right? You've heard about it. You've heard whispers of this coming. You've heard shouts of this coming. It's been published in the paper. Kanye's written a song about it. I mean, golly, but it's here. It's finally here. Y'all are first period. So to jumpstart the unit circle, we are going to actually jump down to example 8, okay? The circle mentioned in the previous examples, which we've actually skipped, is called the unit circle. So very quickly here, unit circle is made up of two words, unit and circle, okay? You know what circle means, right? Round. And unit means measure of length. So a unit circle is essentially a circle that is centered at the origin, okay? So snap to circle. Ooh, that was very generous. Let me do that. Snap to circle. Okay, centered at the origin. So here's the center of the circle. And the radius of that circle, we're going to call 1 unit long. Okay, that's what a unit circle is. 1 unit long. It could be 1 feet, 1 mile, 1 day. No, not 1 day, silly. That's not a measure of length. Unless you're talking about length of day. Ooh, burn. Okay, sorry. In our triangles, that we drew yesterday, the hypotenuse was the radius, correct? When we dropped the perp and create a reference triangle. And we then had this point on the circle called xy. So what the unit circle is going to end up being, it's going to be basically some of the common trig functions for these reference triangles that have reference angles, these central angles, these reference angles of common angle sizes like you studied in geometry. What were those special angles from geometry? Do you remember? Yep. What were they? You had your 30, 60, 90 triangle. Remember that? And then the other one was? Well, those were a way to relate two angles, yeah. The other triangle was 45, 45, 90. It's your special right triangles. 30, 60, 90, 45, 45, 90. Now, what we're going to do is we're going to try and take those, we're going to revisit them, but we want to scale them. We want to rescale them so that they fit onto the unit circle. The hypotenuse, which is the radius, has to be 1 unit long, right? That's what we just said, definition of a unit circle. So let's come down here, and let's start with the 30, 60, 90. Okay, example 8. Draw your 30, 60, 90. So there it is. We're going to call this 30 degrees. We're going to call this 60 degrees, and of course that's 90. If you remember the side lengths of your 30, 60, 90, the ratio of them, the easiest way to start is opposite the smallest angle is the smallest side. What's the smallest angle? 30. So opposite the smallest angle, you can give it a unit length of 1. All right? So then we got the square root of 3 is the next largest side. It's opposite 60. And opposite the largest angle, 90, is the largest side length, 2. So there it is. Your 30, 60, 90 triangle is your 1, 2, square root of 3, or 1 square root of 3, 2 triangle. On your tax or star chart, you were given these, and it was given as 1x, 2x, square root of 3x, if you remember that. And, of course, that x was just your scale factor, right? You can multiply all 3 sides by any number, and it makes the triangle bigger or smaller, respectively. Okay, but that is your lengths, okay? Now, we are going to rescale it, not unlike what I just said with the x. We want to make the hypotenuse what length? If we're trying to fit it onto our unit circle, 1. The hypotenuse is the radius. The radius is the hypotenuse, and we want it to be 1. So what do I need to multiply that by to make it a 1? 0.5, good, or 1/2. So if I do it to that side, I got to multiply all sides by that. So we end up with this smaller one, which you could redraw or maybe copy and paste it and then shrink it, okay? You're going to end up with a 1, a 1/2, and a square root of 3/2, okay? That is your 30, 60, 90. All right, there you go. Boom. Now, let's jump down here, right below there, and figure out what the cosine of 30 degrees is. Okay, so we're not doing coordinate geometry just yet. We're using planar geometry. So 30 is your reference angle. Cosine is adjacent over hypotenuse. In the original one, before I scaled it, the adjacent one was square root of 3, and the hypotenuse was 2. So it should be the square root of 3 over 2. What is the cosine of 30 in my smaller triangle? Well, it's still adjacent over hypotenuse, which is now the square root of 3 halves over 1, which is still equal to what? Square root of 3 halves, okay? So what's cool is that it doesn't matter how big or how small your triangle is, the cosine of 30 degrees is always the square root of 3 over 2. Because that scale factor, right, if you were to come back to the beginning, you'd have a 1x, a 2x, and the square root of 3x. The cosine is adjacent, which would be the square root of 3x, over hypotenuse, which is 2x. What happens with your scale factor of x every time? It divides out. So irrespective of the size of the triangle, the cosine of 30 degrees is never not always what? The square root of 3 halves. Yeah. What is the sine of 30 degrees? It's part B. I'll write it right here so we can still see the triangles. What is the sine of 30 degrees? Well, that would be opposite. It'd be 1 over the hypotenuse, 1 over 2. Or, if you use the smaller one, it would be 1/2 over 1, which of course is still 1/2. So much like the cosine of 30 degrees always being the square root of 3 halves, the sine of 30 degrees, irrespective of the size of the triangle, is always 1/2. Okay, always a half. The scale factors divide out. Okay, sweet. So there's your 30, 60, 90. If we then take that same triangle right here and we just prop it upright like that. So here's the 90, but now the 60 degrees is up here. Oops, that's not how I want to do it. Let's prop it up like this. There we go. So this is the 60 degrees. I'm trying to orient it so that they're going to end up being right there with the origin, with the central angle. There's your 60, there's your 30. If we just keep the side lengths labeled the same way, opposite 30 is 1/2, opposite 60 is square root of 3 halves, and this is 1. Okay? So now 60 is my reference angle, right? It's my central angle. What is the cosine of 60 degrees? Well, since I drew this little coordinate plane here, let's not think about it in terms of SOHCAHTOA anymore. Cosine, remember, is x over r. What's the x coordinate? 1/2. What's the r coordinate? 1. So cosine of 60 is 1/2. That was the same as sine of 30. Okay? What is the sine of 60 degrees? Sorry, sine of 60 degrees. Well, that's y over r. That's the square root of 3 halves over 1, or just the square root of 3 halves. That was the same as cosine of 30. Now, you remember how, real quickly, this is kind of just a real quick explanation. Tangent and cotangent were the only two that were reciprocals of each other, and the other cos don't seem to match with reciprocals. Co does not mean reciprocal. Okay? Notice this. Cosine of 30 degrees is the same as sine of 60 degrees. Bless you. See that? And sine of 30 degrees is the same as cosine of 60 degrees. How are 30 degrees and 60 degrees related, Daro? Two angles that add up to 90, like 30 and 60, are complementary. What are the first two letters that word starts with? CO. Guess what the co means in cosine, cotangent, cosecant? Complementary. You have sine and the complementary function of sine, cosine. Okay? Here's why they're called co-functions or complementary functions. Sine of 30 degrees is equal to the complementary function sine of the complement of 30, which is 60. And sine of 30 degrees is equal to the complementary function of sine, which is cosine of the complement of 30, which is 60. Sine and cosine are now called complementary functions. That's what the co stands for. They're co-functions of each other. You don't fight over who's the brother if you're arguing with your brother, right? I mean, if you're both males, right? So, yeah, if you're 1 and 1, yeah. But anyway, so sine and cosine are complements. 30 degrees and 60 degrees are complementary angles. So sine of 30 and cosine of 60 are always going to be the same because they're complementary functions of complementary angles. That's why they're called co-functions, okay? So keep that in mind. Co doesn't mean reciprocals, it means complementary. So it turns out that tangent and cotangent are not only reciprocals of each other, they're complementary functions of each other. Okay, now let's do the 45-45, and then we'll be ready for the unit circle. Here's your 45, 45, 90. Your unit lengths are 1, 1, and by the Pythagorean theorem, you get the square root of 2. And again, you can multiply all three sides by any scale factor. What do I need to do to all three sides to make the hypotenuse 1? How do I make the square root of 2 1? Divide by, how about that? Divide by square root of 2. Is that okay? All right, what's square root of 2 divided by square root of 2? 1. What's 1 divided by the square root of 2? Well, it's 1 divided by the square root of 2. But I'm going to do this off to the side. I don't like the radical in the denominator, so I'm going to rationalize it, and I get square root of 2 over 2. That's the side length I want. And that's the same as the other one because this is an isosceles right triangle, 45, 45, 90. So there you go. There you go. What is the cosine of 45 degrees? If this is now the coordinate plane and there's your central angle, it's x over r. Here's x over r. What's cosine of 45 degrees? Square root of 2 over 1, which is square root of 2 over 2. What's the sine of 45 degrees? Y over r? Square root of 2 over 2. Yeah, very good. Okay? So because these are both 45, there's not two different versions of it. Whereas the 30-60, we could take the same triangle and flip it. Okay, we are now ready for the unit circle. We have, yeah, we are. We took our special right triangles and we rescaled the hypotenuse to be 1. So here we go. Insert a full page. Insert, add page. Boom. We're going to need a full page. All right. Here we go. All righty. So. Yeah, you should already have those memorized. But no, not. No, let's do the unit circle first, and then you could be like, okay, that's what I have to memorize. Okay. Snap to circle. Boom. Make it bigger. How about right there? And now let's center it up. Good. Straight lines. All right. There we go. Excellent. Okay. So here we go. This is the unit circle. What is the radius size? 1 unit. Okay. So here's the thing. On the unit circle, if I come out right here, 1 unit to the right, what's that ordered pair? 1, 0, right? Now, what angle is that? That is 0 radians. It's also 0 degrees. 0 radians and 0 degrees. If we go all the way around, that is coterminal with 2 pi and 360 degrees. Thank you. Okay? So that one we're going to label as 2 different angles. We're going to label it in degrees. We're going to label it in radians. The ordered pair is 1, 0, and it's 0 radians, 0 degrees, and then go all the way around. It's 2 pi radians, 360 degrees. Okay, we're going to do these easy quadrantal angles first. Okay, now come up here. What's that ordered pair? If the radius is 1, 0, 1. Yeah, don't think too hard. It's easy. You're just navigating around the coordinate plane. Well, that is going to be, I've been listening to radians first. That's pi halves radians or 90 degrees. All right, now let's come over here. This ordered pair is -1, 0. Easy, right? Go left 1, up 0. That is pi radians, also known as 180 degrees. Sweet. And then we're going to come down here, and this ordered pair is 0, -1. And, of course, we know that that is 3 pi halves, and also known as 270 degrees. And then, of course, you make a full rotation, and we've already done that. Okay, so those are your quadrantal angles. Now, those ordered pairs to you right now really mean nothing. We just know the radius is 1 unit. Yeah. Nothing new so far, right? I mean, I'm just labeling. We've done this already. Pi halves, 90 degrees. They're equal, right? We partition circles. The only difference is I'm adding the ordered pairs, which this is not hard. The radius is 1, right? So right one, left one, up one, down one. Now those ordered pairs are going to mean something here soon enough. Right now, this is just how you get there. All right, so now it's going to get interesting. Yay. We are going to look at, and I'll use blue, we're going to look at the first angle that we looked at over here, 30 degrees. Okay, 30 degrees. When we scaled it to a radius of 1, we had those as our ordered pairs, or as the side lengths, okay? So let's come over here to our unit circle, and let's draw a 30-degree line out here. Snap it, okay? It doesn't have to be exactly 30 degrees. Now, normally we're going to, drop a perpendicular, and we're going to label that as 30 degrees. It's going to get really cluttered, if I label all the angles down there at the central angle. And it's going to get really cluttered, so I'm not going to do that. So here's what we're going to do. If you want to drop a perp, you can. All right? Let's do that at least, maybe. Okay, that's going to make a right triangle. I'm going to label that central angle right out here at the end of the line. Okay? That's referring to that central angle. Everyone okay with that? That's 30 degrees. 30 degrees, if you remember, we converted it earlier, is pi 6. Those are the same. 30 degrees in pi 6 radians. Now, what's the ordered pair there? Well, if the radius is 1, that's the hypotenuse. Remember, to get to this point on the edge of the circle, from the center, I have to go right. No, it's right here, right? I have to go right, square root of 3 halves, and up 1/2. Yeah, because the hypotenuse is 1. I go right, square root of 3 halves, and up 1. So the ordered pair there is square root of 3 halves, comma, 1/2. Well, that's why we scaled it first, okay? The horizontal was the x-coordinate. The vertical was the right coordinate. Okay, now, before we move on, what does that ordered pair xy, what significance does it have? Well, remember over here, I asked you what the cosine of 30 degrees was? What did the cosine of 30 degrees end up being? Square root of 3 halves, right? Because it was x over r. But what is r? 1. So it ended up being just the x coordinate, right? Yes. So this right here, when you have the ordered pair xy, the x coordinate ends up being, let me move this over, the x coordinate ends up being the cosine of the angle. And then what was the sine of 30 degrees over here? Remember that? Sine of 30 degrees was 1/2 over 1, which was 1/2. Because the hypotenuse, the radius was 1, it was just the y value. Holy moly smokers. So the y coordinate is always going to be the sine of that angle. That's important right there. So what you're going to memorize is the ordered pair at 30 degrees or pi 6 to be square root of 3 halves, comma, 1/2. And now if I ever ask you, what's cosine of 30 degrees? You're going to be like, square root of 3 halves, yo. I'm going to be like, what's sine of pi 6? And you're going to be like, 1/2. Or if you're JoJo, you're going to say 0.5. And I'm going to be like, yes. Right? What's cosine of 30 degrees? Square root of 3 over 2. Square root of 3 halves. What's sine of 30 degrees? 1/2. Good. It also works for this. What do you think the cosine of 0 is? 1. That's correct. What's the sine of 0? 0. You're correct. What's the cosine of 360 degrees? 1. What's the sine of 2 pi? 0. Yep. Okay. Nope. We're getting there. Okay. Now here's the cool thing. The cosine essentially measures the width of the triangle, and the sine measures the height of the triangle.
Sine, y, height, sine, y, height, sine, y. They all have the I sound.
Cosine measures the width. Now, remember in the alphabet song, A, B, C, D, what comes next? X comes before Y in the alphabet song, and therefore also the alphabet. What comes first in the alphabet song, C or S? C. So it's in alphabetical order. X comma Y equals C comma S. Cosine comma sine. Got it? All right. The cosine measures the width.
The sine measures the height. It's the Y value.
Sweet. Now, if I took that blue triangle, let me do it like this. Copy. No, it won't work. And I reflected it across the y-axis. What's it going to do? If I reflect it across the y-axis, it's going to come over here. And if I drop that perp down right there, okay, I have a congruent triangle, right? This reference angle is 30 degrees. But what is the actual angle that gets me when I rotate all the way over there? What's 30 degrees short of 180? 150. So this is 150 degrees. I'm going to maybe start writing them in here. This is 150 degrees, also equal to pi 6 short of pi would be 5 pi 6. Okay? Let me go ahead and write this in here just so that they all look the same. Put that in there. That way the ordered pair can be a little bit closer. There we go. So 150 degrees and 5 pi 6 still have a 30-degree reference angle. It's the exact same triangle. But because I'm in quadrant 2, I get there by going left and up. So guess what the x-coordinate is? Not square root of 3 halves, but negative square root of 3 halves. And then I go up, so it's still 1/2. Oh boy, oh boy, oh boy. Guess what cosine of 150 degrees is? Negative square root of 3 over 2. Guess what sine of 5 pi 6 is? 1/2. Scooby-Dooby-Doo. Nice. Guess what cosine of pi is? Nope. Cosine of pi? -1. Mira? -1. What's sine of 180 degrees? Also 0. Zero. All right. What if I took that same triangle now and reflected it across the x-axis? I get another 30-degree reference angle right here, yes? So it's a congruent triangle. Oh my goodness, so the side lengths are the same. But because I'm in quadrant 3 now, it's left and down. Guess what the ordered pair is? Negative square root of 3 halves, negative 1/2. They're both negative. All right, so what are the angles that get us there? Well, it's 30 degrees past 180. What's 180 plus 30? 210. It's pi 6 past pi. What's 6 pi 6 plus 1 pi 6? 7 pi 6. There you go. So what is cosine of 7 pi 6? Negative square root of 3 over 2. And what's sine of 210 degrees? -1/2. Oh, yeah. All right, jumping down here just because it's here. What? It's the same thing. You see the pattern? It's quadrant 3. Negative. It's the same triangle. It's the same triangle. Yes, thank you, JoJo. Okay? Now, I'll leave it in field of vision. What is cosine of 3 pi halves? 0. What's sine of 270? -1. Very, very good. All right. Last one. We can either take the triangle from over here on the left and reflect it across the y-axis, or take the first one we drew and reflect it across the x-axis. It's the same thing. Okay, so that's another 30-degree reference angle right there. See it? Another 30-degree reference angle. What is the angle if I'm stopping 30 degrees short of 360? 330. Good. And what's the angle in pi 6 if I'm stopping 1 pi 6 short of 2 pi, which is 12 pi 6? 11 pi 6. Good. So that's the angle in radians. It's the same exact triangle. So we're in quadrant 4, so now it's writing down. So it's positive square root of 3 halves, negative 1 half. Oh, yeah. So, yeah, good. Yeah, you're going to get it. What is cosine of 330 degrees? Square root of 3 over 2. What is sine of 11 pi 6? Yes, negative 1 half. Good. And we've already done the 2 pi one. Okay, so we're done with the 30-degree reference angle. Yeah? Yeah. Next one, I'll choose green. Let's do the 60 now. It's the same triangle, but remember we're standing it up on its side. So that's going to be over here. Right there. Okay? If I drop a perp straight down, there it is. That'll work. Yeah. Right here, 60. Yeah. Yeah. Close enough. You don't have to draw the perp. I just want you to realize that it's triangles, okay? You don't have to draw the perp. All right, so this is 60 degrees, which is also pi thirds radians. Okay, we've done that before too. Now, the ordered pair for that one, notice because we stood it up on end, we have to go from the center right a half and up square root of 3 halves. Which number's bigger, square root of 3 halves or 1 half? Square root of 3 halves, right? So because now the triangle is taller, we go right a half and now up square root of 3 halves. Some people get the ordered pair confused at pi 6 and pi thirds because it's the same numbers. But if you realize that cosine measures the width and sine measures the height, the closer it is to 90, the taller it's going to be. So sine is bigger, square root of 3 halves. And the closer it is to 0, the wider it's going to be. The cosine is bigger, square root of 3 halves. Okay? Well, we've got it listed. So guess what the cosine of pi thirds is? 1 half. Guess what the sine of the square root of 3 halves is? Square root of 3 halves. Yeah. Very good. Now it's going to pick up, right? What if we reflected that triangle across the y-axis? We get this. Close enough, as someone said. I like that. I missed it. I'll make the dot bigger. There it is. All right. So now that is a reference angle still of 60. So if we stop 60 short of 180, that's 120 degrees. Pi thirds short of pi, which is 3 pi thirds, would be 2 pi thirds. Okay? So that's 120 degrees or 2 pi thirds. Now we're in quadrant 2, so it's left and up. So it's negative 1 half, positive square root of 3 halves. Guess what the cosine of 2 pi thirds is? Negative 1 half. You'd be correct. You don't have to guess anymore. What is the sine of 120 degrees? Square root of 3 over 2. See how it works? Sweet. All right. If we reflect that straight down, oops, straight down, and then up here. All right, so there's another 60-degree reference angle. So now we're 60 degrees past 180. That's 240 degrees, or we're pi thirds past pi, pi being 3 pi thirds, we're at 4 pi thirds. Okay? It's the exact same triangle, but now we are in quadrant 3 where it's negative, negative. So that's negative a half, negative square root of 3 halves. What is cosine of 4 pi thirds? Negative a half. What is sine of 4 pi thirds? Negative square root of 3 halves. Good. Sweet. And then of the last one, right? Reflect that across, like there. And there. Now you got another 60-degree reference angle, but we're stopping 60 degrees short of 360, so that's 300 degrees. It's also pi thirds short of 2 pi, which would be 6 pi thirds. So that's 5 pi thirds. And now we're in quadrant 4. We're right and down, so it's positive a half, negative square root of 3 halves. So what is cosine of 5 pi thirds? 1/2. What's sine of 5 pi thirds? Negative square root of 3 halves. Good. And we're almost done. We just have one more angle to go. It is not that bad. Thank you. All right, we're going to do our 45. So the 45 is going to come right here in the middle. Drop it straight down. All right, so that is your 45-degree angle. It's also pi fourths reference angle. Now, the pi fourths reference angle, if you remember over here, when we scaled it down, going from the origin to get here, right square root of 2 halves, up square root of 2 halves. This one's the most boring one because they're both the same. Right, which means it's less likely for you to get it messed up. Square root of 2 halves, square root of 2 halves. So as we already said, what's cosine of pi fourths, or 45 degrees? Square root of 2 halves. What's sine of 45 degrees? Yeah. How are 45 and 45 related? They're the same number, but what do you get when you add them together? 90. So they're actually complementary. So remember, complementary functions at complementary angles have the same trig ratio. That's why sine of 45 and cosine 45 are the same ratio. Okay, that's pretty cool. That is pretty neat. I like it. All right, if we do this one over to here, snap to straight, that's a 45. Tears of joy, I know. Cry tears of joy. All right, we're 45 short of 180. That's 135 degrees. We're pi fourths short of pi, which would be 4 pi fourths, so this is 3 pi fourths. And, of course, we're in quadrant 2, so it's now negative, positive. All right, so what is cosine of 3 pi fourths? Negative square root of 2 halves. What's sine of 3 pi fourths? Square root of 2 over 2. It sure is. Yes. Straight down. I know. Drop a perp. All right. 45-degree reference angle now in quadrant 3. We're 45 past 180. That's 225. Pi fourths past pi. That would be 5 pi fourths. It's the same ordered pair. We're just in quadrant 3, folks. So it's negative, negative. Negative square root of 2 halves, negative square root of 2 halves. So, what is the cosine of 5 pi fourths? Perfect. What is the sine of 5 pi fourths? Negative square root of 2 halves. Wow. Now, you've seen how this has been working out. You could probably imagine what the last one's going to be. No? Well, that's why I'm here, to help you with your imagination. A 45-degree angle short of 360 is going to be 315. Pi fourths short of 2 pi, which would be 8 pi fourths, is 7 pi fourths. We're in quadrant 4 now, so it's right and down, so it's positive square root of 2 halves, negative square root of 2 halves. So, what is the cosine of 7 pi fourths? Square root of 2 halves, good. What is the sine of 7 pi fourths? Negative square root of 2 halves. And that, folks, is the unit circle. That's the whole thing. No more. The clubbing has stopped. All right. So, here's another version of it. Okay? There's another version. That one does? I know. If I would have just thrown that at you, you probably would have fainted. But because we did it together and you know what all those numbers means, you're like, oh, I'm so happy. It's not bad at all. Okay? Absolutely. So, here's the deal. You really only have to memorize the first quadrant. Okay? The rest is just duplicated. Okay? As you come up from 0, you have your pi 6, pi fourths, pi thirds, right? Your ordered pairs are square root of 3 halves, 1 half, square root of 2 halves, square root of 2 halves, and 1 half square root of 3 halves. Again, another common alert, students tend to get those backwards. That's the student who's not thinking, right? Remember that the x-coordinate gives you your cosine value, which is essentially the width, and the sine y height. So, if you are closer to 0, like pi 6, your triangle is wider than it is tall. So the square root of 3 halves has to be first, because square root of 3 is bigger than 1. And as you get closer to 90 degrees, your triangle is taller than it is wide, so the 1 half comes first. So if you memorize this, just realize that everything, and we're eventually going to just do it in radians. So notice in quadrant 1, all of your pi have coefficients of 1. See that? 1 pi 6, 1 pi 4, 1 pi 3. In quadrant 2, your numerator is exactly 1 smaller than your denominator. 5 pi 6, 3 pi 4, 2 pi 3. In quadrant 3, because you're past 1 pi, now your numerators are 1 larger than your denominators, 7 pi 4. And in quadrant 4, it's 11.75, which seems arbitrary, but it's not. It's exactly 1 smaller than twice the denominator. Why twice the denominator? That's once around. So twice 6 is 12, minus 1 is 11. Twice 4 is 8, minus 1 is 7. Twice 3 is 6, minus 1 is 5. Okay? And if you realize that every pi 6 reference angle, 1 pi 6, pi 6, pi 6, and pi 6. Who cares what the pi 6 is? It's always some sort of square root of 3 halves 1 half, yes? It's always some sort of square root of 3 halves 1 half. I would tell you that any time it's a pi 6 reference angle, you know it's going to be some type of square root of 3 halves 1 half. If you could then figure out what quadrant you're in by looking at the coefficient of pi, you know if it's going to be positive or negative. Anytime you see a pi 4th reference angle, whether it's 1 pi 4th, 3 pi 4th, 5 pi 4th, or 7 pi 4th, it's always going to be some type of square root of 2 halves, square root of 2 halves. And again, if you know what quadrant you're in, you can assign it the correct SIG and sign. If you then know that the reference angle is pi thirds, whether it's 1 pi thirds, 2 pi thirds, 4 pi thirds, or 5 pi thirds, you know it's some type of 1 half square root of 3 halves reference angle, or ordered pair. And now, depending on which quadrant you're in, you can give it a plus or minus appropriately. That's the easiest way to do it, okay? And trust me, after 20 years of using the unit circle, if someone asks me what cosine of 7 pi fourths is, here's what I do. Cosine of 7 pi fourths. Okay, that's cosine, that's the x-coordinate. Pi fourths is square root of 2 halves. You said 7, that's going to be in quadrant 4, where x and cosine are positive, so positive square root of 2 over 2. That's still how I do it, okay? Now, real quickly, 2 things. First of all, you're going to learn shortly that if you know the first 2, we'll do this tomorrow, if you know the first 2, cosine and sine, you're going to be able to get all the other 4 just from these numbers. So you're going to be able to eventually tell me all 6 trig functions for all of these angles. Now, let's look at the quadrantal angles. Notice that as you rotate from 0 up to 90 degrees, your triangles are getting taller and narrower, right? So what happens essentially, you could think of the triangle. When we hit the x-axis, what happens to the triangle? It collapses, right? You're squishing it down vertically. Okay, it's getting taller and it's getting narrower and narrower and narrower until it collapses down to a width of 0 on the y-axis. Well, if cosine measures the width, when we collapse that width down to 0 on the y-axis, what should be the cosine? 0, whether you're at pi halves or 3 pi halves. That's why the x-coordinate in the cosine is 0. Now keep rotating. As you're rotating towards pi, now the width is getting bigger again, but what's happening to the height? Now the height is getting shorter and shorter. And when you hit the x-axis, it's like collapsing the height down to 0. Which one measures the height? Y, the sine. So guess what the sine of any angle on the x-axis is, whether it's 0 or pi? 0, right? If sine measures the height, then on the x-axis, the height is collapsed to 0. Cosine measures the width, so on the y-axis, the width is 0, okay? And that means that the other dimension is the maximum possible length, which is either 1 or -1, depending on which quadrant it's in, okay? So that kind of makes that make sense. There's a unit circle. Tomorrow, you are going to have 5 minutes, and you are going to fill this out. You are going to have 5 minutes. I'm going to give you a blank unit circle, and you're going to fill it out. If you would like to practice, time yourself tonight. Go to the Precal Matters page. Scroll down to 5.3, and you see this link? Blank unit circle. I am literally going to give you that right there. And you are going to have 5 minutes to fill out everything in 5 minutes. I would fill out all the pi 6s first, then all the pi 4ths, and then all the pi 3rds. Instead of just filling it out as you rotate around, it's a lot faster. Practice tonight, practice tonight. You could do it. People finish in like 1 minute, and then they pick their nose for 4. All right? Just practice, practice, practice. Have a fantastic rest of your day.